Time for Pure Math 2. Pure Math 2 is one of my favorite subjects. So let's see what this paper has in store for us. It is the October-November 2023, obviously Pure Math 2, and this is paper 2-2. I haven't seen this paper before, so let's hope for the best. Okay, when a polynomial is divided by x plus 2, the remainder is 33. Find the value of the constant a. Okay, so here we're going to use the remainder theorem. So if it's divided by this factor, that means I'm going to plug in my root of minus 2, and my answer should be 33. So they haven't labeled this polynomial as px, so I'm just going to do that. Okay, I'm going to plug in my minus 2. 7. And this is going to give me minus 8a plus 16a plus 14 minus 5. And this should actually be equal to 33. So I can work out my a directly. That's 24. So my a must be equal to 3. Cool, that is question 1. Just a quick 2 marks. Okay, straightforward question, no part B's to that one. Next, solve the equation sec theta times cos theta, and then I've got a compound angle here, is equal to 4. Okay, so they're just giving me an equation, and I need to find all the values between minus 180 and 180. So just watch out. These days they seem to be giving domains that go into the negative as well. So that's important just to take note of. So what I see here, my sec can be written as 1 over cos. And then I've also got a compound angle here, which I need to expand. So I am going to, I think, just start expanding. I'm quickly getting my MF19. Okay, so make sure you have your MF19 with you. I'm going to put a big bracket here because I'm going to expand this and it's going to have more than one term. So I've got my cos of theta cos of 60 plus sine theta sine 60, and that's equal to 4. I should have just written this as 1 over cos theta. Okay, now when I'm multiplying in, so I'm going to multiply this into that term and into that term, I get, my cos's are cancelling out, so cos 60 plus sine over cos is the same as tan theta, so sine 60. Okay, and then cos theta is a value that I can put into my calculator. Well, it becomes just numerical. Sine of 60 is root 3 over 2. Okay, if I isolate my tan theta, I've got 3.5 here. This gives me 7 root 3 over 3. And so now if I get the inverse of tan, I just plug in that answer and I'm getting a value of 76.1 degrees. Okay, so that is my reference angle. It's not my only answer, so I've got to go and find what are my different answers in this. Okay, we need to be looking in the interval of minus 180 and 180. So I always like to just have a sketch on the side. I know that goes to 90, and then 180 is over here, and I've got minus 90, minus 180 is over here. So this is where I'm looking, and I was looking at 7 root 3 divided by 3, which is a decimal of, it's about 4.04, so I'm looking for all my answers. So here I can see So this is about 4.04. I'm basically looking for two answers within this domain. So I've got my 76.1, and then I know that tan repeats itself every 180. So if I take 76.1 degrees, I'm then going to subtract 180 from that. And I get minus 103.9 degrees. So I like to sketch because then it can show me exactly how many answers I should expect to get. Or let's rather write the other one first. So minus 103.9 degrees and 76.1 degrees. I expect two answers. Those are my two answers within my domain. Okay, let's jump over to question number 3. So this looks like it's going to be an integration question of some sort. Okay, the diagram shows the curve of y is equal to 6e to minus half x. The points on the curve with x coordinates 0 and 2 are denoted by A and B respectively. The shaded region is enclosed by the curve. The line through A parallel to the x-axis and the line through B parallel to the y-axis. Okay, find the gradient of the curve at B. All right, so gradient of the curve, that means we find dy dx of the curve, and we plug in our point B, which is 2. So if we're looking at this, this is just a normal exponential function, so I can just integrate it directly. Well, not integrate it, sorry, differentiate it. So I keep my coefficient, I derive my e, which stays the same. I keep the inner function as it is, and then I need to multiply by the derivative of the inner function. So my total is minus 3e minus half x. Okay, that's my dy dx. Now I need to plug in a point. They do say find the exact gradient. That's minus a half times 2. So my answer is going to be minus 3 times e to the minus 1, which is the same as minus 3 over e. Okay, that's my exact gradient at that point. Okay, find the exact area of the shaded region. Okay, so we are going to be doing integration here. What I'm going to first do is I'm going to work out the area of my rectangle. I'm going to do the full rectangle. If I look at that, so I need to know where does it cross? Where does my graph cross the y-axis? Okay, so I've got to take my y is equal to 6e to minus a half x. I'm going to make x equal to 0. So that just becomes the power of 0. Anything to the power of 0 is 1. So my y is 6. Okay, so my length of my rectangle here is going to be 6 and my width is 2. So my rectangle is 6 times 2, which is 12 units. Okay, an area under the curve. So I'm going to subtract the area under the curve. Here I'm integrating between 0 and 2. And we are integrating in terms of x. Okay, let's just see there's nothing strange about that. So now I'm integrating under the curve. That's going to give me this area, and then I'm going to take my 12 units and I'm going to subtract that area. That seems quite straightforward. Okay, so to integrate this, I keep my coefficients, I integrate my e, and then I divide by the coefficient of x, and I can do that because my inner function is linear. Okay, so 6 divided by minus a half, and that is something I definitely should not be using my calculator for. Okay, now I'm plugging in my 2, and I'm plugging my 0. Here you've got to be careful because when you plug in 0, it doesn't make the term disappear. Okay, often the term disappears, but not when you've got e's and sometimes trig functions. For example, cos of 0 is not 0. Okay, So just watch out for that. So e to the minus 1, and this becomes a minus, times a minus is a plus 12. Anything to the power of 0 is 1, so we're just going to say plus 12. So this is minus 12 over e plus 12. So that's the area under the curve. Okay, so now they want the exact. You must watch out for these keywords. The exact area of the shaded region. So we know it's going to be area of the shaded region is 12 minus this answer that we got. So 12 minus 12, those kind of cancel out, and the area of my shaded region is just 12 over E. Okay, that's my final answer. All right, watch out for the blank pages in between. Don't necessarily write on them. If you need extra space, go and write on the additional paper. And don't think you've reached the end of your exam if you find a blank paper in between. Okay, let's go. So sketch on the same diagram the graphs of that and that. So the first thing I want to note here is I've got a mod and I've got a straight line. Okay, the way that these are written is a little bit funky, so I'm just going to rewrite this. Because it's a mod, you can swap those x and y and x around. Okay, and this one I'm going to say minus 2x plus 9. That's just the format that I understand better. Okay, so if you were to draw this, we know this has been shifted 3 units to the right. And it's a normal V shape, so it's a gradient of 1. So that's quite nice. They haven't, so that's 3, and that's also going to go through 3 on that side. And then our straight line needs to pass through 9. So I might just extend this a little bit. Okay, hopefully you maybe planned this a bit better in your paper. So 3, 6, let's say it goes through 9, and it has a gradient of minus 2. Okay, so that's steeper than this gradient. This has a gradient of 1. The other one's got a gradient of 2. So what I just do is I want to see where does it cross my x-axis. So I make y0. So 2x is equal to 9. X is equal to 9 over 2. So that's 4.5. 4.5, somewhere around there. Okay, so the idea, all that you need to see is that the one graph is steeper than the other one. That's generally what they're looking for. And that it does cross the axes in the correct place. Okay, so also remember to label your x and y axes. And so here, whenever they tell you to draw these things, it usually helps you answer the questions below. Okay, so yeah, they're saying solve the inequality, and they want to know where is the mod greater than the straight line. Okay, so just for interest, I can already see that that's going to be over here. The mod anywhere from this point onwards, my mod equation is above my straight line. If I go to the left-hand side, I can see my mod is below the straight line, and the straight line has a steeper gradient. Okay, so it's only going to be from that point forward. So there's different ways to solve this. If you're using your graph, you can literally see that I'm going to use my right arm of my graph. So x minus 3 must be greater than 9 minus 2x. Okay, and this is now quite straightforward. So 3x is greater than 12, x must then be greater than 4. Okay, and that does make sense according to where we plugged in our intercepts and things. Okay. Okay, so x must be greater than 4 only, there's no other values. So if you were to do it only algebraically, yeah, you would probably get an answer that's not valid, or you would only get one answer, maybe be a bit confused. So always just check. If they do get you to draw a graph, it normally helps you answer the question below it. Okay. Now, use logarithms to solve this inequality. Okay, I just want to see, is that at all relatable to solve that inequality? Give your answer in the form x must be less than a, where a is given to 3 significant figures. Okay, so I don't see too much correlation between any of the question above and this, so I'm just going to treat it separately for now. If I use logs, I'm going to say log, you could say log all in. Okay, ln 2, 3x minus 10 must be less than ln 500. Okay, whenever I'm dividing through, if I've got a ln or log inequality, I must just make sure I'm not dividing through by negative numbers, because then my sign must flip. Okay. Anyway, I'm bringing this down now. 2 must be less than ln 500. Okay, so I want to solve for x. So I'm first going to multiply out. Minus 10 ln 2. Okay, and I'm going to keep ln 500 plus 10 ln 2. So my x must be less than ln 2 is still a positive number, so I can divide by it. 3 ln 2, so x must be less than, and they're just asking for value to 3 significant figures. So I am not going to solve these. I'm not going to try and simplify them. I'm just going to plug it into my calculator. And this gives me an answer of 6.32. It's 3219. Okay, an interesting question, not many lines that they've given you to do it, so just be careful. Okay, what is this now? List the integer that satisfies both of these inequalities. Ooh, this is an interesting question. So that's why they've thrown it into the mix here. List the integer that satisfies both of these inequalities. Okay, so we want the mod to be greater than the straight line. Okay, so we want the mod to be greater than the straight line. So that's x must be greater than 4. List the integers, okay? And here, x must be less than 6.32. So what are the integers between 4 and 6.32? So we've only got 5 and 6. Those are the two integers. I'm not going to include 4 because it says it must be greater than 4. And I can include 6 because it must be less than 6.32. Okay, so that is a creative new way of asking a question. So just when you're doing this, you really need to have your problem solving caps on, and just be warned that Cambridge will definitely send you things that you've never seen before. Okay, next. This is interesting. We've got another polynomial division looking question. Okay, so find the quotient when that is divided by that. Okay, so when they say find the quotient, then we can't just plug in, we can't plug this in and just find the remainder. We're going to have to do polynomial division. Show that the remainder is 6. Okay, that's kind of them, because then we can know if we're doing the right thing or not. Okay, minus 24x minus 4. Okay, so what I'm looking out for here is, do I need any placeholders? So it doesn't look like it. Always make sure that you do have x3, x2, x1, x0. Okay, now we're just going to do polynomial division. I'm not going to go too much into detail of how to do that, but you divide your first terms. So 6 divided by 2 is 3, and x squared divided by x is, or x cubed divided by x is x squared. So when you multiply it back, that must be the same as the term that you already have there. And then plus 3x squared. So divide, multiply, subtract. That first term must always be 0. And then now I've got minus 5 minus 3. Minus 8x squared. And then we bring down our next term. Then we divide our first terms. So that becomes minus 8 divided by 2 is 4x. Okay, and then we're left with minus 8x squared minus 4x. Divide, multiply, subtract. So minus 24 plus 4, because it becomes minus minus. and then we bring down, and here we have minus 10, and we bring down. This is looking good. Minus 4 minus minus 10 is going to be minus 4 plus 10, which is 6. Brilliant. So we've got our quotient, which is 3x squared minus 4x minus 10, and our remainder is 6, just like we were asked to prove. So that's nice. It gives us some confidence. Okay, now they're saying hence. Okay, so we've got to use what we just did to solve this question. Hence, find the integral of this. Okay, giving your answer in that format. Okay, so we're going to go to Lin's afterwards. That's interesting. That also does give us a tip, though, that we're probably going to use Lin in our integration. So in order to integrate this question, we're now going to look rather at our quotient. So 3x squared minus 4x minus 10. And then we had a remainder of 6, which hasn't yet been divided. Right, so this is how I'm going to set up my integral for now, because here I can integrate this and I can integrate each of these terms. Here I'm going to be using my ln, and that's great because I actually need a ln in my answer. So I can't integrate this big fraction unless I break it up, and that's why they wanted us to do that in part A of the question. Okay, so here we go upper power, divide by the new power, upper power, divide by the new power, and here we've got to go ln, and then we must make sure to divide by the coefficient of x. Okay, it's a definite integral, so we're going between 7 and 2. I'm just going to simplify this before I plug anything in. So 6 divided by 2 is 3 ln 2x plus 1. Now we're going to plug in a 7. Two times 7 is 14, plus 1 is 15. I'm just going to do that all in one. And I'm subtracting, and then I'm going to plug in my 2. Plus 3 ln 2 times 2 is 4, plus 1 is 5. Okay. Right, so they want us to give an exact answer here, so I'm going to put some things in my calculator, but I'm not going to put my lns in. Okay, so here I get 175 plus 3 ln 15. I don't need the mod anymore because 15 is a positive number. And then minus, so 2 to the power of 3, 2 times 2 squared. That's minus 20 plus 3 ln 5. Okay, so now I've got 175 minus is plus 20. Okay, then I'm going to take my 3 up. Ln 15 to the power of 3 minus ln 5 to the power of 3. I can now combine my lns, and now I need to use my 15 to the power of 3 over 5 to the power of 3. So when it's negative, it means I can divide. And if I just simplify that, so 15 to the power of 3 over 5 to the power of 3, that gives me ln 27. And they wanted me to give an answer of A plus ln B, where A and B are integers. So this looks about right. A is 19 and B is 27. That is my final answer for this question. All right, let's jump into question 6. The diagram shows a curve with parametric equations. Okay, so when I look at this, I see a ln. So this has got like an inner function in it. And here what I'm seeing is the product rule. Okay, Whenever I think of parametric, first thing that you think of with parametric is your formula. So you need to know dy over dx is dy over dt divided by dx over dt, and this is on your MF19, so it's just at the bottom section of differentiation. So you don't need to learn it off by heart, but that formula should come to mind whenever you think of parametric. Okay, so we're definitely going to be differentiating here. The curve crosses the y-axis at the point A, all right? At the point B, the gradient of the curve is 12. At the point B, okay, that's interesting. The gradient of the curve, so dy over dx is 12. Find the exact gradient of the curve at A. Okay, so A is where x is equal to 0. Okay. I just have to orientate myself here. So x is equal to 0. That's great. So find the gradient of the curve. Okay, so we know we need to get dy dx. That's just a good place to start. Divided by dx over dt. So we're going to have to find the derivative of each of these. So x is 3 ln 2t minus 3. So dx over dt, differentiating x in terms of t, is going to be 3 over 2t minus 3. And then we also have to multiply by the derivative, which in this case is just 2. Okay, and then our y is 4t ln t. Okay, so here we've got to use the product rule. So if you go onto your MF19, that is your UV rule. Okay, I just do a shortcut here. I don't write it all out. So I say, so we've got the product of two things here. So differentiate the first, it's just going to be 4. Keep the second, plus keep the first, and differentiate the second, 1 over t. So if I were to simplify this, I would have 4 ln t plus 4. That's my dy of dx. No, that's not my dy dx. That's my dy dt. Okay, so now I can find dy dx, which is actually the gradient of this graph. So here you can see we've got a graph of x against y. Okay, so that's why we need to find dy dx. And that is dy dt, so 4 ln t plus 4 divided by 6 over 2t minus 3. Okay, so dy dx, I'm just going to rewrite this, 2t minus 3 over 6. I don't know if that actually makes anything simpler or not. Basically what we need to know what is the value of t. Okay, so they want to know, they say it's, well, point A is where x is equal to 0. So let's make x equal to 0. I'm just going to do that on the side here. If x is equal to 0, 3 ln 2t minus 3 is equal to 0. So I can take I can divide through by 3. Okay, then I can e both sides. E to the power of 0 is 1. Minus 3 plus 3. 1 plus 3 is 4. So t is equal to 2. Okay, so if I plug in 2, 2 times 2 is 4 minus 1 minus 3. I've already done the maths. My brain is going faster than my hand. Okay, what does this give us? 4 ln 2, and what did their question ask? They want the exact gradient. Okay, so I'm not going to plug 4 ln 2 in my calculator. I'm going to say ln of 2 to the power 4 plus 4, and that is going to be multiplied by 1 over 6. And this gives me an answer of, okay, so we could do this in 2 different ways. What's the best way to do this? Yeah, I'm actually going to take this down again, just because I can see that I can simplify a lot here. So if I have 4 ln 2 plus 4, I can take 4 and divide it by 6, which is going to leave me with 2 over 3. And that also gives me 2 over 3 ln 2 plus 2 over 3. So there's different ways you can write this. I think you can argue as to what's the simplest process. They didn't necessarily ask for a specific format. They just wanted it in an exact format. And so that's what I'm going to leave mine as. Yeah, you could also take the 2 up as a power and leave the whole thing divided by 3. That would be fine as well. Great, so we found the gradient of the curve at A. Now it says show that the value of the parameter t at B satisfies this equation. Okay, so now we mustn't allow these confusing words to confuse us. To show that the value of t at B satisfies this equation. So let's just go, what is happening at B? They told us that the gradient of the curve is 12. So at B, the gradient of the curve is 12. Okay, so they've given us dy over dx. If I write down my simplified version, I had 4 ln t plus 4 multiplied by 2t minus 3, and this was over 6. And now we know that that answer is equal to 12. So all that I do is I take the information that they gave me for B and I write it out in maths. So the gradient is 12 and this is at point B, okay? And now we got to make one of these t's the subject of the formula and hopefully we'll get to the equation that they've got up there. Okay, so 4 ln, I just want to double check, it should be ln t. Okay, so I confuse my t's and my 4's. This is t. 4 ln t plus 4. Okay, so I'm just going to multiply my 6 through for now. 12 and 6 is 72. Okay, so my thinking process here is I can see I've got a ln t that's at the bottom of my equation. So that's not going to be the t that's the subject of my formula. So my subject of my formula is most likely going to be this t over here. Okay, so if I just start by saying 2t minus 3 is 72. Oh, there's a lot of confusing letters here. 72 divided by 4 ln t plus 4. Okay, so I can see that this thing I can at least divide by, I can divide everything by 4. So that's going to be 18 over 2 ln t. No, not 2, just over ln t plus 1. Okay. Right, so we're getting something that's looking a little bit similar over here. Now I'm going to take my 3 to the other side. Ln t plus 1. That becomes a plus 3, and then now I'm dividing by 2. Okay, and that becomes 3 over 2. All right, we got to what we needed. Cool, that's encouraging. So the trick with these, I can see I'm in a numerical analysis. They're probably going to ask me to iterate in the next question. So how do I know that? Because they've asked me to prove an equation, and there's a t on both sides of the equation. So that would be the trick. What you need to figure out is which t is the subject of the formula, and then just go for it. Okay, right, so here we're jumping right into our iterative formula, which they ask us to use. So use an iterative formula based on the equation above to find the value of b. Give your answer to 3 significant figures. Use an initial value of 5. Okay, so they've given us T1 is 5. Give each result to 5 significant figures. Okay, so I'm just plugging in 5 as my value. So 9 over ln 5 plus 1 plus 3 over 2. That gives me an answer of 4.901234 Okay, that's 5 significant figures. Now here you just go back on your calculator and instead of, you just plug in your answer. Okay, T3 is 4.96262. Next one, 4.9595897. 1, 2, 3, 4, 5. Okay, I've 1, 2, 3, 4, 5. Oh, I'm not doing this to 5. Okay, so instead of 8, 9, I'm just going to put dot, dot, dot because I didn't round that one off. 1, 2, 3, 4, 5. Ah, 1, 2, 3. Okay, I'm not doing very well with my rounding off here. T6. 1, 2, 3, 4. This can become a 7. 1, 2, 3, 4. That should actually be an 8. Okay, how many do they want? They want us to give the result of 3 significant figures. Okay, I'm just pushing equals quite a lot of times, and I'm noticing that my first 3 don't change. So my final answer, I'm going to give a final answer of 4.96. And that is that question. So really nice iterative question. Let's jump right into the next one. Okay, so here we've got some trig. I'm probably going to need my MF19 to prove that that is equal to that. Okay, what is this? Okay, so there's still quite a big question coming up. Prove that that is equal to that. So how do we start these questions? Left-hand side. Okay, I cannot see what I'm going to do yet, so I just need to start somewhere. Okay, so I know that I've got my sine of my double angle, so I could expand that. So do sine x cos x. Okay, I could also rewrite my cot. Cot is the same as cos x over sine x, and tan is sine x over cos x. Okay, I'm just starting somewhere. So if I multiply this in to each term, my sines are going to cancel out for the first one, and I'm going to be 2 cos squared x. And then for the second one, my coses are cancelling out. Sine squared x. Okay, looking good so far. So now I've got a cos squared x and I've got a sine squared x. Now, when I look at my final answer, I've got a cos double angle. So I just want to go to my MF19. I can see that I have a double angle here of cos squared A minus sine squared A. That's going to give me a double angle. I find that interesting. Okay, I don't have that at the moment. I don't have a minus at all, so I can't use that directly. Let's just try another route. So 2a is equal to 2 cos squared a minus 1. So I could possibly change my cos squared. I could actually directly change my cos squared a. That can become cos of 2a plus 1. So I could change that directly. And then I've also got a cos 2a is equal to 1 minus 2 sine squared a. So I could change 2 sine squared a into 1 minus cos of 2a. All right, so I'm just going to give this a go. Let's change this directly. So this becomes cos 2x plus 1. Yeah, cos of 2x plus 1 plus, and now I only want to change 2 sine squared. So I've still got a 3. And then my 2 sine squared becomes 1 minus cos 2x. Okay, now I have 4. So plus 1 minus 3 is minus 2 cos 2x. And that is my right-hand side. Brilliant. Okay, so you just kind of got to start somewhere. It's really nice to have it at the end. What I like to do is write down my identities on the side and just actually work out what is equivalent to what. Don't just try and eyeball it. It's very easy to make mistakes. Okay, hence, find the exact area, the exact value of this. Okay, so we just need to see what is going on here. So that can be related to, if I look up here, I've got a cos x and a 3 tan x. I mean a cot. So here I've got a cot and a 3 tan. So I can see that my x is equivalent to 1 over 12 pi. Okay, so if I can find the value of that, and my x is related to 1 over 12 pi. All right, so I know cot x plus 3 tan x is equivalent to, and this whole thing should then be divided by sine 2x. Okay, because they didn't have the sine 2x on the other side. I'm going to put it on this side. Okay, and I know that x is pi over 12. So 4 minus 2 cos of 2 pi over 12. This gives me okay, and these I can work out nicely. So you either will know these are special angles. You should actually know them without your calculator. But you can put in your calculator as long as your calculator is in radians. Because it's good to show all your working out for something like this. Okay, so what I did there is I just flipped my sign over. Well, not flip my sign, I flip my denominator over. Okay, and then I get 8 minus 2 root 3. All right, last question in this paper. It looks interesting. Let's see what they have to offer us. So the diagram shows the curve of that for x between 0 and pi over 2. Okay. Okay, so what we've got is a transformed cos graph. So y is equal to 4. So we know that this is going up for 4. It's got an amplitude. It's going up till 6. That goes down till 2. And it is squished. So this goes between, that goes to 2 pi, which means b over here is just pi. Okay. At the point A, the gradient of the curve is 4. So dy over dx is equal to 4 at the point A. Maybe we can just I'm going to put that over there. The point B is a minimum point. Okay, so here we've got dy over dx is equal to 0. The coordinates of A and B are A and B respectively. Oh, the x coordinates. Show that the integral between A and B is 3 pi plus 1. Okay, this is an interesting question. I'm not sure what they're leading up to here, but why don't we just plug in our values? So if I look, okay, so I'm going to need to know what is A. The gradient is 4. All right, so we just got to start somewhere. How much space did they give us? Okay, 4 minus 2 cos of 2x. Okay, my gradient dy dx is equal to, so my 4 is going to fall away. Minus 2, my cos becomes sine. Cos becomes minus sine. And then we're going to multiply it by 2. So it's 4 sine 2x. And we know that the gradient at A, so if I plug in A, my answer is going to be 4. Gradient at A is 4. Right. So sine 2A is equal to 1. Okay, so the inverse of sine is pi over 2. That seems to make sense. So A is pi over 4. Okay, I feel like I could have just already known that without doing any calculations, because that's going to be pi over 2, that's pi. No, that's 3 pi over 4. Okay, and that's pi. Anyway, B is also equal to pi. I think we kind of know that. So maybe I didn't need to do that calculation, but at least it's there. I derived it and I've calculated what is my value of A. B, I'm going to say is equal to pi. Now I'm going to integrate. And you should have an MF19 with you. I feel like it would be much easier. Okay, so this we're going up in x minus 2. Cos becomes sine. Okay, I think that's straightforward. I haven't checked my MF19, but I think that's correct. Or let's plug in values here. Or let me just simplify first. So 4x minus sine 2x. Whenever you need to make a neat column for yourself, so always start writing as far to the left-hand side as possible. This is going to be pi over 2. Okay, and we're actually proving something here, so that's nice. We know if we've got it right or wrong. Sine of 2 pi, so you should be able to do this without a calculator, that's just 0, minus pi plus, that becomes 1. So 4 pi minus pi is 3 pi plus 1, and thankfully that's what we needed to do. Okay, so I don't actually know why that's worth 5 marks, but there we go. That is it. That's this paper. I hope that that helped you, and if you are writing soon, all the best for your exams. So I just realized I was quite zoomed out there, so here's my calculations for this last question. But all the best for your exam. I think Pure Math 2 is a lot of fun. I hope that your exam goes really well.